It's my great pleasure to welcome Paul Nelson, who's innovation lead with Accenture, and this is the part of Accenture that some of us knew and loved as Search Technologies, but I have to get used to saying Accenture. So Paul is going to talk to us about search and the enterprise data lake, all about ingesting, interpreting data. So, Paul.
Great. So is this microphone working? Yes? Okay, great. So, you know, when I think about knowledge management inside the organization, I think about breaking down barriers and breaking down silos, trying to get the organization to talk to itself across organizational barriers and across tools and across individuals, transferring of knowledge throughout the organization. And for the longest time, search engines have been one of the best silo killers, silo breakers, silo destroyers in the world. Because you can search anything into a search engine and it can search over it all, and everything is just one query away. So this is, you know, why Google won over Yahoo, because Yahoo had a big directory and that was siloing everything into this you know, hierarchical directory, and then Google wanted something very flat so you could do everything was just a query away, okay? But a second technology has come upon us, which is the second greatest silo killer, and that's the data lake. And so everybody is putting all their data into a data lake, and it's really breaking down barriers inside of an organization so that knowledge can be shared in a super, super powerful way. And so that's kind of the perspective that I wanted to communicate today, is that using a data lake is an incredibly powerful way to create a shared understanding of the organization across all the types of knowledge that exist within the organization, and then also to start using machines to help you synthesize that knowledge across all of that raw content. So we are the Search and Content Analytics Group, and my marketing department had me put in the one marketing slide. We are a part of Accenture now. We're about 200 search engine experts. And you know, we focus a lot on unstructured content, search engines, natural language processing, big data, and high volume ad hoc analysis. So we'll be talking about data lakes and connected knowledge. And one of the things I think about knowledge management, you know, employees should only need to remember one destination for everything. And that should include not only the unstructured files, or what you can find on a website, but also, I believe, all the structured content as well. And they should have only one place to go to enter a customer name, a person name, a project code, a billing code, as well as, you know, a few keywords or topics or whatever. Everything should be able to be one query away. And some of the common use cases for navigating the organization, I mean, typically it's all been about navigating the organization and possibly locating past work artifacts. Now finding colleagues and experts, policies and procedures, but here we have knowledge, right? Knowledge of our business, knowledge of our customers, knowledge of our company, knowledge of our products. A lot of that is in structured data sets or some kind of combination between structured and unstructured data sets, where mashing the two together inside of a data lake could give you something very, very powerful. And so, you know, at Accenture as well, you can enter into here things like Accenture Interactive. Now that's a group inside of Accenture, and now you're linked into the group graph, which shows you all the different organizations within Accenture and how they interlink with each other. Or you can get to time and reporting, that's navigation, policies and procedures. I had to fake the companies because, you know, I have to fake the companies. So projects and companies and people and topics and various destinations. So ideally you want to get to all these things, not necessarily just files, right? And not files or websites. It's a whole range of knowledge. One of the other things I think that's interesting about the world today is we talk about content capture and how the amount of curation and the value to the organization. I mean, you have financial systems which are heavily curated because they are money, okay? And so you know that the dollar amount that you're paying for this thing is accurate because it's money. And so people put a lot of effort into making money accurate. And then you get to things like Documentum and document management systems, master data, corporate websites. So, but as the curation goes down, generally the content blows up. And the least curated thing is like email. But what we're discovering is that we can put this into a data lake and we can kind of start mashing things up to, against each other and using machine learning in essence to have the machine help curate our uncurated content. So to use the machine for a better understanding of what the content's about, what it's referencing, what its quality is, and so on, and using the machine, so you combine these parts together, take the highly curated parts, match them up against the uncurated parts, and help to sort of lift up the gems that are in that uncurated content into a way that they can be really, really leveraged. But you have to have it all together, right, in order to be able to do this. And that's what the data lake is about. Sticking it all together so that you can like mash it all up and then kind of add 2 + 2 = 5 to give you better content from the uncurated stuff by mashing it up with the curated stuff, and vice versa, right? You can learn more about your customers by looking at the sentiment of the emails that talk about them, right? You can learn more about your employees by looking at the emails that talk about them. You can find bad employees, employees who are doing insider trading, you know, all kinds of evil things that are happening. And our customers are actually doing that. They're taking all the emails, they're looking for dangerous things that customers are doing because otherwise they could be subjected to enormous fines. Okay, so moving on. You know, I think that context is necessary. I mean, we have all of this. If we had an email and we didn't know who it was from and who it was to, that would be a really useless email. And so, you know, context is so important. And one of the things that we're talking about is how organizations today are starting to move from left to right. That is, everything had been a sort of a tools orientation. You had your email tool, your chat tool, your document management tool, your project management tool. And what we see is like with things like Microsoft Teams, tools are now being centralized around a topic. So you create a team, and inside that team you have chat and files and wikis and everything that's centralized around a topic. And so now we're getting, like with Microsoft Teams, you get this topic orientation. Now, one of the things that would be helpful is if you could have the connected topics. And so some of our customers have actually put a layer on top of Microsoft Teams such that you cannot create a team directly. Instead, you have to go to a website before you can create a team, and then that website actually gets information from you about what the team is about. So you have to enter a project code or a customer code or some sort of concept or an employee ID or an organizational ID in order to create the team. And now you have that Microsoft team with all the tools, and you know how that's linked into like the organization as well. That gives you context about everything that's happening inside that team, and then that context will really help you when you're trying to do connected knowledge, that is extracting items from that content and then really understanding what it's about. So, you know, I see this sort of a trend moving forward. And then I just, you know, also wanted to talk a little bit about the knowledge delivery cycle. The idea that employees, you know, you have a job to do. So you do that job on some business system that has some digital work output. That digital work output can now be harmonized, extracted, and correlated, and written into a common knowledge base. Meanwhile, employees who have work that they need to do, they need knowledge in order to do their job. They then express that knowledge as some sort of digital expression of that knowledge need. We now interpret that. We now get a semantic representation of that and fetch that knowledge from the knowledge pool. We can now help with natural language generation to get that back to the employee. Now they can use that knowledge, of course, on their business systems and their work product. And so what we have is sort of a cycle which goes around in these sort of figure eights, which allow you to extract knowledge and then write that back into the business system, and then use that knowledge from the business system to further enrich the knowledge that is then passed on to future employees. And so this is how sort of I believe the knowledge system should work. But what ends up happening is in a lot of systems today, those work products are not connected. These arrows are missing. You're not actually getting the data from where people are actually doing their job and then putting it into a knowledge management system such that future users can actually use that information. Instead, users are expected to take time out of their work to write up some policy or procedure or some instructions and then put that into a special document management system. So it's not part of the standard cycle. It's outside the standard cycle. So I just wanted to encourage, really your business systems ought to be the ones that are providing the knowledge. It shouldn't be a separate document management system or a separate knowledge management system. It should be the business as a whole, which is generating knowledge just by virtue of doing work. Was there a question in the back? Or you're just counting? Okay. Okay, so I just wanted to give an idea. Okay, so we've been talking a lot about knowledge. I wanted to give an idea of what I think knowledge is. Okay, so we're going to go through a few things about what knowledge is. And so some scary charts which we've generated from some large manufacturing organizations. And so this is just sort of an example for a large manufacturing organization, sort of how knowledge flows through the organization from original research to manufacturing engineering to prototyping to product design and architecture to systems integration to customer installation and customer delivery, physical machines to troubleshooting and testing and quality testing. And so we have this sort of system where knowledge is being generated at all these different parts. And you look at this organization and you say to yourself, there is no lack of knowledge in this. Every point in here is producing all these artifacts, but they're not being used and synthesized and joined together in a way that makes them useful and accessible by everybody. And so what we're doing with these sorts of companies is trying to map where all the knowledge is inside the organization as just an ordinary part of doing their job, making sure that knowledge has some contextualization to it, is linked with identifiers so that we can start joining and connecting things together, and then putting it in a data lake so that we can start, mashing it up and then delivering it to people when they need it. So these are just various domains of knowledge, the corporation, suppliers, science, parts, platforms, physical systems, research, design, manufacturing, installation, testing and analytics, and customers, contracts, site facilities. So just various different sort of domains of knowledge that's more than taxonomies. It's really a whole large network of these entities and how they're related, which can include millions, if not tens of millions, of different entities and how they're put together. And sort of as a sample taxonomy to a knowledge graph, this gives an idea of the different types of objects that are inside this organization. Materials, fabrication, lab notebooks, customer organization, contacts, roles and responsibilities, test procedures, test parts, part catalogs, raw materials, device processes, specifications, vendor parts, drawings, marketing programs, assembly instructions, bill of materials parts, tiger team communication. So there's a whole, very rich set of interconnected objects. And we would like to know this and to be able to connect up all these different pieces such that when you come into this network, we know who you are, we know what you're connected to, we know that system and where it came from, and then we can start linking you to the system that's broken and all the people and organizations that can help to solve your particular problem. Okay, so when I was talking about knowledge and knowledge graphs, I wanted to emphasize that knowledge is not just one sort of thing. for us, knowledge is this combination of items. It's the files and metadata like we've always had, but also concept graphs, which link up all the concepts in the organization, connected business entities like customers, parts, systems, and products, and how they all interrelate, a language model, which understands synonyms and acronyms, and all of the different language that's being used inside of an organization and how it's being used and what it represents. Virtual agents, I think, is really part of this sort of knowledge space. That a virtual agent is like a computer that knows how to solve problems for you. And so, we want to link it into this knowledge integration hub. And then this is sort of my own invention here, an idea of intelligent access methods. That is, ways to access business systems to extract information that may be, the most up-to-date. And so that could be an intelligent API where I can go fetch the latest information about a part or about a customer or about an employee. And understanding how to access those APIs in order to access that information. Or to do things like reserve a conference room, or identify when the bus is coming up next, or all those sort of very practical things. So when we talk about the data lake, we're expecting that the data lake encompasses all of this information here. That business systems, like your financial systems, your HR systems, SAP, is actually providing this data, which gives us these connected business entities. Customers, parts, systems, and products. As an example, one of our customers is an airline customer. They have reservations, ticketing, check-in, loyalty. There's one I've forgotten. 5 different systems that they've all ingested, and then they've started mashing that up together so they have one notion of what a customer is. That would be a passenger. And so they have a big database of passengers, all the flights that passenger has taken, and then all of the special requests that passenger has made. And then you start doing data science on that to determine, is this a business passenger or a pleasure passenger? And then those flights and everything is being linked into the graphs of all their airline equipment and the different processes and procedures that they have. And so that's where knowledge should include not just documents, but every single one of your customers and how they interact with the system into sort of one holistic understanding of your organization. So then files and metadata, those come from often document management systems and websites, which are loaded into the content. And then we have a knowledge integration hub, which takes parts and mentions of products and customers and parts and systems and whatnot, and mashes them up against the content to identify how they're all interlinked. And then concept graphs as well, which identify higher level concepts like blockchain or sort of organizations and parts and locations and things like that. So that all those parts start coming together. And I think I got all kinds of time. So in terms of the architecture, this is really just about getting the structured content into the system. This is a kind of a standard system for ingesting structured content for business systems, getting the tables, starting to mash up the tables, creating a set of final entities, and then delivering that into a search engine like Elasticsearch and doing further analysis of it. But for me, that's just sort of half the equation. We have the structured content, and that comes into the connected business entities, and that's what this is trying to show. But there's also, of course, the unstructured content, which comes from all of your document management systems, and we like to mash those up together inside of the data lake. So just a little bit about Accenture, because we're doing this inside of Accenture as well. Accenture today, we have 460,000 employees. We operate in some 200 cities in 53 countries. And 1.4 million searches per month. Index is refreshed every day, and aggregated data from 50 different types. So it's really quite a rich environment. And then just to show you, in terms of links into the knowledge graph, these are example links into the knowledge graph where you can enter an Accenture group, and you get the Accenture Interactive. And now this is a node in the knowledge graph, and then this is a group within Accenture, and now we have linkages to key people from that group, and other key documents like their stage 0 deck and their other customer communications. So now we've got a link into that knowledge graph, and we're starting to link out from that to other places in the knowledge graph. Here's me. So I'm a link in the knowledge graph. I'm a node in the knowledge graph. I've been ingested from the HR system. I think I've been ingested actually from 4 different systems inside of Accenture. And then all of my data has been merged together to create this one common record, which has been indexed into the search engine, which includes all of how frequent a blog poster I am, how high I am in the organization, how many counselees do I have, how much activity do I have inside the organization, and other aspects. And then we also have a concept graph, which is information about key concepts that are important to our customers and important to our employees, so that I can enter blockchain, and now I get a link into that knowledge graph about blockchain, where I start to get things like learning about that, connecting and exploring, getting in touch with other people, like who are the experts in blockchain, and where can I get the authoritative information. And so what we're seeing is that the search is gradually drifting from being a simple list of documents and it being your responsibility to explore those documents and to read them and figure out all of this stuff, into something that's a little more curated, such that you enter a concept or a node in the knowledge graph, and now you're linked into the knowledge graph, and then that's the graph of all the business entities, the people, the projects, the items inside your company which are important to your company. And now you can start linking out and doing actual work, or calling somebody and asking for some help, or identifying what the best content is about a subject. And so that, this is kind of where I see it heading, and it's data lakes which are making this possible, because we can put all that data together and start mashing it up against each other. So this is just some other things that Accenture is doing in terms of auto-tagging the content, personalized content recommendations. And this is the people connector, which is another example of how the data lake makes these sorts of things possible. Because we know what content a person has written, and we know what the list of people are, we can start mashing those two up and identifying who you might be connected to. So if I've written a lot of similar content to someone else, it can start connecting me to that person. If I've worked on similar projects, or I'm about to work on a similar project in a similar role, these are this sort of business data we can start matching up and connecting to the individual person to try and start connecting you to other people. And this just shows that the results so far have been good. Okay, so the other thing about getting this sort of knowledge from the data lake at a very specific level is, you can start asking questions now. Now that you have your data described in a knowledge graph, both from your structured and unstructured contents, you can start asking questions like, in these Wikipedia examples, who is Morgan Freeman? What is the population of Italy? Chart the population of the United States. And so now we're starting to elevate the knowledge management system from being simply a document delivery system to being a true conversational knowledge management system, which can actually start interacting with the user in a conversational way. But it's only because we have that machine-readable representation of the knowledge of the organization that underlies this, which allows us to actually start asking questions and answering questions like this in a reliable way. Okay, so sort of the last two parts of this is I'm going to talk a little bit about what a data lake enables in terms of machine learning and deep understanding. And then I'm going to go through I'm going to build up a reference architecture which shows you how to put all the parts together to create your own data lake. And then, we'll open up to questions, and we can go through. I've been trying not to talk specifically about various technologies because, in part because the technology space is evolving so quickly. I could give you an answer today, and it would probably be different tomorrow. But we can feel free to talk about those sorts of things as well. Okay, so in terms of an end-to-end knowledge management framework, the sorts of things that includes an intelligent enterprise strategy for capturing all that content, a knowledge capture strategy, knowledge connectivity and distribution, and then an integrated data backbone so that we can get all that structured and unstructured content together. Looking at the very bottom, we have structured and business data that comes into the data lake and needs to be mashed up and merged together. So there's a lot of table merging, cross-application merging, deduplication, and doing linked objects into the knowledge graph. There's a lot of language understanding, language detection, semantic analysis, entity extraction, natural language processing. We're starting to see a lot more image and video processing. Images of accidents, for example, and using machines to automatically try and understand what the what they're seeing inside of the image, but also images that are important in one of our oil and gas resources organizations. We have images of seismic cross sections and images of well logs, and so we're starting to ingest those sorts of things and using machine learning to understand what the image is and how to get useful information from it. In terms of, so these are very business-related images that are important to the business. They could be products which are damaged, people, events, things that have scans of invoices, scans of forms, scans of claims, pictures of license, my driver's license, all those sorts of images which are coming into the system, which we would like to link into the knowledge graph so that if I have a picture of a driver's license, I'd like to know whose driver's license that is. Is it an employee's driver's license? Is it a customer's driver's license? And link it in to the appropriate place so that we have that information appropriately linked into the knowledge graph of the organization. And then sound, because that's for, mostly that's for things like customer support, like recording customer support calls and trying to identify from the tone of the call, is the person angry or upset, and on a scale of 1 to 10, how angry or upset they are. And then doing speech to text, so we can actually start getting automated transcripts of that information. And then now that you have a transcript about it, you'll know what they're talking about. And so then you can start linking that conversation into your knowledge graph so that you can have a deeper understanding of what people are saying about your product, or whether you're running into problems, where are things to fix, what support engineers are better at talking to customers or better for certain types of projects and things like that. Okay, so then we have a series of APIs and methods. One of the things I think that's very powerful about being in the computer business today is that machine learning and deep learning is really just exploding. And what it gives us is the ability to scale this understanding of our knowledge by using machines to help us understand our knowledge. And so it allows us to scale, whereas you would have had to have a human read documents and manually classify them. The machine can now read the document and classify it almost as well as a human can. It can extract entities, it can extract relationships, it can start to extract procedures and processes, can identify images and start linking those things into the knowledge graph. And then, of course, search engines for delivery and similarity comparison. And then, the various capabilities that you develop as an organization: text analytics, image analysis, knowledge correlation, video analytics, data integration, and virtual agents. Okay, so let's sort of talk about how one goes through this journey. It's not like I walk into every customer and say install a data lake, right? Customers need to go through a certain journey. They need to have certain connectivity. And so, we try and encourage everybody to move one step further from where you are to something that's a little more integrated, a little more comprehensive, more accurate search, better understanding of your content. And so at the very bottom, we have some sort of business system where you ingest some sort of content with content processing into a search engine, and then we have an application which is a portal search. And so then that's like, the baseline for any knowledge management system is you stick in what used to be the Google search appliance, right? It crawls your content, And now you have a search. And many, many hundreds of thousands of organizations, that's sort of the minimum of what knowledge management means. So sort of the next step for us is to then do a little deeper processing on that content. Well, in addition to having more content coming in, so that's always one thing, you can now start getting your SharePoint content, getting your Documentum content. But I think the next sort of functional step is we have some notion of binary storage where we operate with content processing. And that's where you would do things like store images. And your content processing now does OCR. So now you're doing OCR of images, and you want to get those images. And maybe you're also taking snapshots of all of your PowerPoint presentations so that you can show slides in your search results and sort of reduce the distance between the user and the content. And so this is sort of multiple renditions of the content, and it's available to be accessed directly by the portal so that it can fetch that information very quickly from the binary storage and browse through it very quickly, rather than having to go all the way back to the business system to fetch the content. And so that's where we start to understand the content a little better. We make additional binary renditions of it. I'd say almost all knowledge management systems of a sort of a corporate scale will ultimately have some sort of binary storage for thumbnails and medium-sized images and other versions of videos and extractions from Microsoft Word documents or PowerPoint documents or whatever. Okay, so now it's time to stick in the data lake. And so this is where we start to ingest both business structured content and unstructured content together into a raw data lake. And now our content processing can be a lot more rich in terms of mashing those items up against each other. We can now take that cleansed, structured, and conformed content into the search engine and make that available to the portal as well. And so now the big data lake is being used for all of our content processing and our content cleansing and essentially creating a conformed view of that. The next step is to provide, at this point, I think we have enough data so we can start doing question answer, and we can add a virtual agent to start helping, actually solve problems. And then that virtual agent is likely going to need to have access to the original business systems. Like if you're going to reserve a conference room with a virtual agent, or if you're going to change your address with the virtual agent, you want that virtual agent to reach back into the original business system to actually change your record or reserve the conference room or do whatever you need to do. And so, again, we like for the virtual agent to show up on the portal. We don't like for the user to have to go to a separate place for the virtual agent. We like that to be a single experience. And then if you have an app, we want people just to ask questions on the app. For the application to decide, is that a question to answer, is it a search, or is it a virtual agent request, and then give you the appropriate response. So you can have a single place to ask all your questions and fetch all of your information. And now this portal application becomes a broker between search, question answer, and virtual agents, and decides where it goes, or it goes to all places and then chooses which one ever has the best response. So the next layer is knowledge processing. Now that we have all the data in the data lake, we can do some more substantive knowledge processing, and that includes image extraction, text extraction, entity extraction, classification, and then relationship extraction as we start linking all these items together. That now creates a series of knowledge artifacts, which are the actual knowledge graph itself, all the linkages between all the entities and how things are interrelated. And there's a ton of artificial intelligence and machine learning training that goes alongside to produce all that information. And now we have semantic interpretation, which we've added into the search, which allows us to say, well, I'm looking for these sorts of things. I know that this is a person, that's an action, that's a project. And now I know a lot more information to give me a much more targeted response from the knowledge artifacts. And also they'll link me directly into that knowledge graph. So that's that link here where I'm showing nodes from the knowledge graph and I'm now starting able to navigate around. And then up top we have just data management layers, governance, data cleansing, security, data architecture, data modeling. Okay, so this is a little project plan where we would just come in and assess the current needs, the implementation plan, look at content ingestion, do some business entity extraction, other semantic extractions, and so on. So I think that's pretty much what I had. We're good on time. I know I talked a lot and was very quick about it, so I thought, I guess I'm hoping that there'll be some questions afterwards that we can discuss. I'm sorry, the knowledge. Can I have that on? The knowledge integration hub here.
Yes.
Yes.
Sorry. That's okay.
There's no single tool which is the knowledge integration. This data lake is for most of our customers an instance of Cloudera or Hadoop. The knowledge integration is a series of Spark scripts that pull the data from the connected business entities, the knowledge graph, and the raw text data, and is integrated with some natural language processing to start extracting entities. So, there's no tool that is this knowledge integration hub. The entire data lake is this sort of lake of knowledge. And then we have these, robots that are usually written in Spark, sometimes Python Spark, sometimes Java Spark, which pull and start mashing things up and then taking their results and then writing the results back into the connected business entities, writing the results back into the concept graph, or tagging up the files and the metadata such that the output can then be sent to search and used to deliver search. Yeah, I think what I was trying to show here is that knowledge is a multifaceted thing. There's not just sort of one file where you can point to and say that's the knowledge for the organization. There is a whole data lake full of files, which is collectively the big pot of knowledge, which is everything you know about the company, as much as you know about it. And that includes, usually customers, parts, systems, and products. These are big Avro files of large structured tables with interlinking identifiers. The concept graph could be an actual knowledge graph, like a triple graph of some sort. Then you have the actual files and the tagging of the files and the entering of the files. And sort of collectively, the fact that they're all interlinked with common identifiers, it collectively gives you the knowledge of the whole organization. And so then as new business data comes in, those files are recomputed every day using big Spark jobs to keep them up to date. We recalculate the class. We reclassify things to link things up to the knowledge graph. We do we re-extract from all of the unstructured content if a new employee came in, or we had an employee's name changed, or maybe their name was corrected. Everything gets recomputed very frequently, and that's one of the advantages of the data lake, is you have all that raw content in there, and you have this knowledge integration is this massive pool of Spark jobs essentially, and so you just run them all every day, and then recompute everything every day, and then re-push that out to the search engine. So it's not like we're going through a knowledge and individually adjusting nodes or things like that. You're kind of going back to the raw content and then rederiving everything that you can rederive. Is that helpful? It's a different look at it, right? But this is where the world's headed. There's no one file, there's no one structure, there's no one way of representing knowledge. I mean, I have an image, and that image shows me a broken part, and it's broken in a certain way. I want to save that image and kind of annotate it with how it's broken and why it's broken, and then link that into the part that's in, you know, the concept graph or somehow, so that, you know, when I'm going around and designing the next version of that part, I can see images of the broken version of the old part. So it, you know, it's this collection of objects and artifacts which are all linked together, that together make up the knowledge of your organization. And we want it to be flexible, and we want it to be, you know, very, very...
At first, thanks for the interesting presentation. Where do you see permissions in the data lake? Are they included? Are they important there? And how are they related to analytics based on the data lake?
Oh yeah, that's a good question. You know, all of our document management systems, at least with the files, ingest all the access control lists with all the files. The business systems, it's sort of hit and miss. Sometimes we get a control, an ACL for every record. Sometimes we get a control for just the record as a whole. Inside the data lake, things tend to be, you know, organizations are not that mature in terms of propagating access control lists with the data that they use. And so it's kind of up to the people who are doing this knowledge integration to decide how secure do the outputs need to be, where do the access control lists come from, and who's allowed to see it. Oftentimes there'll be a PII zone and a non-PII zone, so that you know, we have a lot of special checks to make sure that there's no personally identifiable information that goes across those zones, and that files that go back and forth, you know, are protected so that we're not leaking any personal identifiable information. But it's very immature, right? About all that we're doing is ingesting the ACLs and then keeping those ACLs around, and then making sure that the ACLs get correctly to the search engine so that the search can provide only the documents you're allowed to see. That's about as far as we've gotten there, and it's very, very handcrafted. There's not like a systematic way of handling that across all the different types of processing. Yeah, the only other thing I'll say is that, you know, having everything together and becoming experts at mashing up your structured content against your unstructured content is wonderful for GDPR, right? Because now you know where all the people are in all of your unstructured content. Ideally, you have a scan of some page, you know, maybe an employment agreement or something, and in that you've OCR'd and you remembered where every character that you OCR'd originally came from. So when you find the name, you can go back to the image and stroke it out, right? So, you know, become very savvy about maintaining all that whole provenance of extraction allows you to also be very savvy about forgetting and very targeted about forgetting, which I think is, you know, part of what you get by putting all of your structured and unstructured content together and treating them as a single knowledge resource rather than separated knowledge resources.
Okay, actually we are out of time.
Really?
So, yeah, believe it or not, it goes fast. What can I say? So thank you all very much for coming. We appreciate that you spent your 3 days at Enterprise Search and Discovery Conference, and we hope to see you again next year. Closing keynotes for all of the combined conferences are down at the end where the lunch was today. So thank you, and thank Paul.
Thank you so much.